This question is given in GATE 2006. They are saying that there are two types of cache organizations, and one organization is, the first one is 32 KB cache, which is two-way set associative with the block size of 32 byte size, and the second one is the same size and a direct mapped cache, right? So one is set associative and other is direct mapped cache. Now the size of an address is 32 bits, which means the physical address size is 32 bits. That is what they are saying in both the cases. Okay, in both the cases the physical address size is same and the cache size is same, but the only difference is one is using direct mapping and other is using set associative mapping, right? And then they are saying that a 2 to 1 multiplexer has a latency of 0.6 nanoseconds, which means they are talking about the hardware latencies which are used in implementing this. Okay, so a 2 to 1 multiplexer latency is 0.6 nanoseconds, while a k-bit comparator has a latency of k by 10 nanoseconds, which means they are talking about the latencies. Okay, latencies of the devices, hardware devices which are involved in this implementation, right? And then the hit latency of the set associative organization is H1, while that of direct mapping is H2. Then they are asking what is the hit latency of set associative and then direct mapping. So in order to answer this question, you should really understand how does the hardware work. I mean, how does the caching hardware work and what are the various delays involved in order to find out whether the required block is present in the cache or not. So we already know that if this is the cache, we already know some few things about it. So if cache is going to be divided into lines, this is what you know, and every line is going to have some tag bits, and these bits are going to help us to identify whether the required block is present in the tag or not, in the line or not. Okay, and now if these are the tag bits, right, then what happens is we have to choose, let's talk about direct mapping, then we shall talk about set associative mapping. In direct mapping, given any physical address is going to have three parts. One is word number or block offset, right, and other is line number and other is tag. These are the three parts. Now the one interesting thing about direct mapping is we need not search and compare in all the tags. We exactly know where to look for. The main memory itself contains something called as line number, and you can directly go into that line and you can look into that line tag, and if the required memory is present there, you can find it out, right? So that is the interesting advantage of tag direct mapping. Then we using this line number, we have to go to the exactly that line. So in order to do that, we are going to use multiplexers. So multiplexers are going to take this line number as input, and then it will choose the lines, the tag lines corresponding to the exact line, which means we'll have multiplexer, right, and this multiplexer will be connected to all the tags like this. All the tags it will be connected, and now you have to just say which tag you want to read, right? Since it is connected to all the tags, it will show only one of them as output. Now using these lines, the line numbers, you just tell it what is that you want to look at, right? So if the line numbers are given as input, right, and then it is connected to all the lines, right, then you can find, it is going to give as output the selected line tag. So if the line selected is, let us say, line number 10, then the corresponding line number 10, let us say it is this, then it will take this tag bit and will give it. But the problem with this multiplexer is it can read only one bit from the tag, but if you have lots of bits from the tag, in order to read every bit, we have to have more than one multiplexer. Therefore, I am going to have lots of multiplexers, and each multiplexer is going to produce one bit out, and all of them put together is going to produce the tag bits. How is it possible? It is possible because every multiplexer can be configured to read one particular bit of the tag. For example, the first multiplexer can be configured to read the first bit from the tag, and the second one can be configured to read the second one from the tag, and third one can be configured to read third one, like this, right? So every every block is going to be everything is configured in such a way that we can go and get that some particular bit in the tag. Got it? And now all of them combinedly are going to produce as the tag bits, right? And then there is something called as comparator. So comparator is going to take the entire tag bits given in the address, and then it is going to find the tag bits of the corresponding line, and then it is going to compare, and in case if both of them match, it is going to say yes, hit, otherwise it is a miss, right? So the time taken to find out whether the required block is present in the cache line or not is actually time taken to pass the signal through the multiplexers and then through the this comparator. Now even though we have these many multiplexers, we need not add all the times. So all of them, the signal is going to pass through all of them in parallel. Therefore you can just take one multiplexer propagation delay, not all these multiplexers propagation delay, and then you can just take one comparator delay. That's it, right? And now they are saying that, okay, how big should be the how many comparators multiplexers are required here? The number of multiplexers required here will be equal to the number of bits in the tag. That is one thing. And how big should the multiplexer be? This multiplexer should contain those many input lines as there are number of lines, isn't it? So and moreover, this input means there are two things, these are select lines and these are the inputs. The select lines should be equal to the number of lines, number of bits in the line number, and the number of inputs should be equal to the number of lines in the cache. For example, if there are L bits, right? If there are L bits in the multiplexer, then what could happen is, if there are L bits in the tag line number, then how many inputs should be there for the multiplexer is 2 power L. Therefore, the size of the multiplexer here has to be, the number of input lines for this multiplexer has to be 2 power L by 1, right? And the number of select lines should be L, where L is the number of lines in the number of bits in the line number. Got it? And then the second thing is the comparator. They are talking about the comparator. They are saying that the comparator delay is depending on the size of the comparator. Okay, how big should be what should be the size of the comparator? That depends on, we need only one comparator in case of direct mapping, right? So we need only one comparator, and the size of the comparator has to be equal to the number of the tag lines, right? So now if we can find out these two things, so what is it? The size of the tag lines, then you can derive the size of the delay of the comparator, right? We need only one comparator here. Now let's talk about this direct mapping. In direct mapping, they are saying that in both the cases, the block size is 32 byte. Therefore the word size is 2 power 5, so 5 bits are there in the word size, right? And then cache is containing 32 KB, right? 32 KB is the cache size, and they are saying that block size is 32. Therefore in case of direct mapping, the number of lines will be equal to 1K. If there are 1K lines, which means 2 power 10 lines, then how many bits are required in the tag, in the line? 10 bits, right? And now they are saying that this total number is put 32 bits. Physical address is 32. That is what they are given, isn't it? So if you watch it, they are given that physical address is 32 bits. So already 15 is removed. Then how many bits will be tagged? 17 bits will be tagged. So this is how direct mapping is going to be used. So direct mapping has 17-bit tag, and then 10-bit line, and then the word size is 5. Okay. Now how big the multiplexer should be? The multiplexer size should be this is 2 power 10 lines are there, right? The multiplexer should be 2 power 10 to 1 mux should be required, right? But if you watch it, they have given that we have a 2 to 1 multiplexer. It is not 2 power 10 to 1, which means they didn't say anything about these multiplexers. So normally the time taken to pass the signal through the multiplexers is very, very less. So what you could do is you could completely assume that this delay is 0. Then why do you think that this 2 by 1 multiplexer is given? That one is given for the set associative mapping, which we shall discuss later. Okay. So now assuming that this is 0, then the only delay required will be comparator delay. Now how big is the comparator? So we need a comparator whose size is 17 bit, right? So the comparator is 17-bit comparator, right? And now they are saying that the k-bit comparator has a delay of k by 10 nanosecond. Therefore 17-bit comparator will have a delay of 17 by 10 nanoseconds, isn't it? Which means 1 by 7 nanoseconds. So in this question, in order to find out whether the hit latency of the direct mapping, so hit latency of direct mapping is H2, the answer for H2 is 1.7 nanoseconds. Okay, fine. Was the question? Consider two cache arc. Okay, I think we have already read the question. Now we have to solve the second one. The second part is about the set associative, right? So let's see what is the hardware required for set associative. In set associative, what we'll try to do is we'll divide the physical address into three parts. One is word number or block offset, and second one is set number, not the line number, set number, and the third one is tag. Now if we have cache blocks like this, okay, then if we have the lines, now the cache is again divided into sets like this, sets, isn't it? Now they are talking about two-way sets, right? Two-way set associative. Two-way set associative means each set is going to contain two lines, therefore two tags are present, right? And then using this set number, you should again use the multiplexers logic in order to select one of the sets, right? And then once you select one of the sets, it's not just reading it from one tag. Now we have to read from the two tags, because your required block can be present in any of the lines. Let us say this is the set which is selected, and now if you using the S bits, this is the set which is selected. Then our multiplexers logic is going to read this one and then this one, and both of them will come out, right? And then again they will be compared with two comparators parallelly, right? So there have to be two comparators, and these two comparators have to be compared parallelly, and then after this comparison you have to go the result through the OR, which means it could be either present here or here. Therefore your output is going to say whether which one, if it is present here or here, right? Then what should be the number of multiplexers and size of each multiplexer? Size of each multiplexer should be equal to the number of sets, right? And then after the sets, it should be able to read, okay, one bit only, right? Then how many number of multiplexers are required? The number of multiplexers required will be equal to the number of tags into 2, number of bits into tags into 2. So why is this so? Because each multiplexer can read only one bit, therefore the number of multiplexers required to read one complete tag is equal to number of the tags, and then we have to read two such tags in parallel. Therefore if the number of the bits in the tag is, let us say t bits are there, then how many multiplexers are required? T into 2 multiplexers are required. Why? 1 T multiplexers are required to read it from one, and other T is required to read it from the other. So in general, if it is k-way set associative, then the number of multiplexers required is T into k multiplexers are required, because we might have to read parallelly from k different tags. And then what should be the size of each multiplexer? Size of each multiplexer should be, each multiplexer should be able to select one among these many sets, right? So how many sets are there? If the S bits are there, 2 power S sets are there. Therefore size of each one is 2 power S to 1. So we need T into k multiplexers, and the size of each multiplexer should be 2 power S into 1, 2 power S to 1, right? And then to how many comparators we need? K comparators we need. So what is K? The set associativeness, right? And then we need a OR gate. Now in order to solve this question, again you have to find out what is the tag bits, because comparator size is depending on the tag bits. Okay, so let's see this. Now they are saying that the block size is 32 bits, therefore the word number is here 5, and then we have to find out the set number. For that we need to find out the number of sets. So in order to find the number of sets, we have to find the number of lines. number of lines equal to cache size divided by block size. So how much is this? Cache size divided by block size is 1k. So 1k lines are there, right? And it is a two-way set associative mapping. Since it is two-way set associative mapping, the number of sets equal to 1k by 2, right? So k by 2 is nothing but 2 power 9. 2 power 9 sets are present. Therefore, here it is going to be 9 bits. Now it is combinedly 14, right? Then how much this should be? This should be, I think, 18, right? Since this is completely, this has to be 32, this has to be 18, isn't it? 14 plus 18, 14 plus 18 is 32, right? So 18 bits are present in the tag. So if the tag is going to contain 18 bits, then what is the size of the comparator? Comparator is 18-bit comparator. Even though there are two comparators, the action is, the comparison is going to get performed in parallel. Therefore, you need to include only one delay. So what is the delay because of the comparator here? K by 10. What is K here? 18. So it is 1.8 nanoseconds is the delay for the comparison. Then what about the multiplexers? How big multiplexers do we need here? It is 2 power 9 by 1, which means 512 by 1 multiplexers are required. Size of the multiplexer should be 512 by 1, but nothing is mentioned about 512 by 1 multiplexer. Therefore, you can consider this multiplexer logic as zero propagation delay. And then we need the OR gate, but OR gate is not given, right? So in order to implement the OR gate, they have given 2 by 1 multiplexer. In digital logic, I have shown you how to implement a OR gate using 2 by 1 logic, right? Therefore, this time taken for this one is going to be 0.6, right? So 1.8 plus 0.6, I think it is 2.4, right? So the answer for this question now is 2.4. So the hit rate H1 is for, I think, set associative, isn't it? The hit latency H1 is 2.4 and the hit latency H2 is, I think, 1.7. Got it? So that is how you could solve this question. The answer is this. So the problem in this question is they didn't mention about the multiplexer logic. Actually, multiplexer logic is also involved. That is why if they didn't mention, I am taking it as 0, right? So that is how you got 2.4 as the answer. Fine.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. and these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.